All right, here we are on page 6 of the packet. We're doing this first horizontal launch example. So we're going to be applying some of those problem types from our green sheet here. So I have a ball or something rolling off a counter that's 1.8 meters high. And I want to figure out how fast was it rolling if it lands 0.8 meters away from that counter, let's say. So the first thing I notice is that this coin or this ball or whatever is moving both in the X direction and in the Y direction. So I list my variables, both my X's and my Y's. I also notice that it is a horizontal launch, meaning that if I resolve the initial velocity into components, I find out that the X component is all of the initial velocity and the Y component is 0, because it's not initially moving vertically up or down. Now the next thing I notice is that this is projectile motion. It's moving in the X, free fall in the Y. So because it's projectile motion, it's moving in the X, free fall in the Y, I know my acceleration here is 0 meters per second squared, meaning these two velocities are the same, and my acceleration in the Y direction is negative 9.8 meters per second squared. So just because I know it's moving in the X, free fall in the Y, the only thing acting on it is gravity, and gravity only acts in the X direction, so that's the only place I have acceleration. Now the horizontal launch portion, that tells me that this initial velocity is V0 and this initial velocity is 0 meters per second. All right. Now when I also have projectile motion, I also know that these two times are going to be the same. Okay. And that's the same for 2D motion as well. All right. So let's go ahead and set this up. So I see my acceleration is 0, so I automatically know what equation I'm using. I'm using equation number 2, so I have x equals x0 plus v0 xt plus 1/2 at squared is 0. Crossing off, that's 0, so this is 0. So how did I know that the initial position was 0? Well, I need to choose where is my origin at. I like to choose it so I always end up with a positive height, so I choose height 0 here, and I always end up with a positive x position, so I choose x equals 0 here, and so that means my origin is right here. So it starts at x equals 0, ends at x equals 0.8. So it starts at 0 here, ends at 0.8 meters. In the Y direction, it starts up at the top at 1.8 meters and ends at the ground, 0 meters. Now remember, when it ends at the ground, I'm talking about the instant before it strikes the ground, not when it hits the ground, the instant before it strikes the ground, okay? So when I get to this point here, I notice that, I have 0.8 equals V0 X, or we'll just call it V0 because they're the same thing here, T. I have two unknowns. So I can't solve it there. So what I need to think about is, where could I find one of these? Well, time is the same in the Y direction. So what I want to do is I want to find time in the Y direction, then use it over here in the X direction to find V0. So I need to pick an equation that's going to allow me to find time. So I want to pick an equation without V final. So that is equation number 2. Y equals Y0 plus V0 yt plus 1/2 ayt squared, crossing off the 0, and we're solving for t in here. So I'm going to move my y0 over, so I have negative y0 equals 1/2 ayt squared. Divide my 1/2 ay over, so I have negative y0 divided by 1/2 ay equals t squared, and then I take the square root. Of course, when I take that square root, I need to put a plus or minus, but I want the positive time, yes. So since I want the positive time, I will leave it as such. So I can plug in my numbers here. So I have negative 1.8 divided by 1/2 times negative 9.8. The negatives cancel, thank goodness, since I'm taking a square root here. And I get a time of something like 0.606 seconds. Make sure you store that or use second answer or go up and highlight it for when you plug it in over here. So I now have 0.8 divided by 0.606 will give me an initial velocity of 1.32 meters per second. And there we have our solution. So it was leaving that table at 1.32 meters per second.